sort of the focus mainly of my research is looking at the interactions of those and how we can increase both milk fat and milk protein synthesis. So previously in the last few years, we've had a lot of studies that have shown that actually increasing the supply of amino acids to what we think 100% of the requirements are increases milk protein, but it also increases milk fat. And it's doing that mainly by increasing de novo fatty acids. So part of my goal here in my PhD program is to chase that and understand where that relationship is in the mammary gland, how are amino acids important to increase milk fat synthesis. Some of our hypotheses is that, the mammary gland is full of all this protein synthetic activity. So maybe amino acids are important for those enzyme structures, some signaling mechanisms directing nutrients where they need to go, or maybe just as an energy source.
All right, welcome everybody to this episode of the Dairy Podcast Show. I am your host for today, Gail Carpenter, and I'm joined by Alex Benoit. Alex is a PhD student at Cornell University. She had her master's degree at Michigan State, something that a school that she and I have in common. We were talking about before we started recording, and she's back at Cornell for her PhD after doing her undergrad there. So welcome, Alex. Welcome to the podcast. We're excited to chat about your research today. Are you from New York? Is that where you started going to Cornell, or are you from somewhere else?
So I'm actually from northern Vermont, right on the Canadian border.
Okay.
So I'm about 6 hours from home. So I'm just a state over, but it feels very homey to me here in New York.
That's far. It's a good distance, far enough away that you can kind of do your own thing, but close enough that it's easy to go home and.
Yeah, exactly.
Stock up on maple syrup and the maple candies.
Yeah, the cream candies. Those are really good.
But enough small talk. We need to talk about your research, which is really important and exciting. So do you want to just go ahead and talk to us a little bit about what the focus of your research program is?
Yeah, thank you for having me. So when I was at MSU doing my master's, I mainly focused on the relationship between milk fatty acid sources and milk fat. So looking at de novo mixed and preformed and how those all come together to synthesize triglycerides and increase milk fat synthesis. So that was mostly focused on fatty acids and increasing milk fat. And when I was looking for PhD programs, I was familiar with Cornell and Mike Van Amberg's lab here, focused mainly on, at the time, amino acids and understanding amino acid requirements and supplies. So I was really interested in sort of marrying those two ideas together. So evaluating the interactions between dietary fatty acids, dietary amino acids, and then how those sort of interconnect to increase milk fat and protein synthesis. So sort of the focus mainly of my research is looking at the interactions of those and how we can increase both milk fat and milk protein synthesis. So previously in the last few years, we've had a lot of studies that have shown that actually increasing the supply of amino acids to what we think 100% of the requirements are increases milk protein, but it also increases milk fat. And it's doing that mainly by increasing de novo fatty acids. So part of my goal here in my PhD program is to chase that and understand where that relationship is in the mammary gland, how are amino acids important to increase milk fat synthesis. Some of our hypotheses is that, the mammary gland is full of all this protein synthetic activity. So maybe amino acids are important for those enzyme structures, some signaling mechanisms directing nutrients where they need to go, or maybe just as an energy source. They're oxidizing some of those amino acids to use for energy, although not all amino acids fall into those categories. So part of my goal is to understand where that relationship is, and then sort of use that information and understand how we can formulate diets to balance amino acids to drive milk fat synthesis, and then maybe bring in some dietary fatty acids to further, supplement and increase milk fat synthesis. And then also how can we maybe play around with the ratios or the different nutrients to increase milk fat and milk protein.
Natural Biologics is using cutting-edge science to deliver cost-effective solutions for the animal health and productivity challenges you face. For conventional or organic production systems, Natural Biologics can help support rumen health and immune function, mitigate pathogens, and increase production efficiency. Visit naturalbiologics.com to learn more.
I'm excited to talk to you about this because it's such a timely topic. I think everybody listening knows that milk fat is just gone crazy.
Yes.
Like since I was in college to now, and not even that long, right? Just over the past like 5 or 10 years, seeing what milk fat's done is just, it's kind of crazy what the Holstein breed can do. And so that's been really exciting, I think, for me to see. But now we're hearing more talk about, well, maybe we have too much milk fat, and it's not necessarily too much milk fat, but relative to milk protein, like we need the protein too, right?
Yes.
And so I'm really interested to hear what you have to say about increasing both of those, because that's certainly something that I think we're going to be seeing a lot more interest in the coming years, or months even.
Yes. Yeah, it's been very interesting for us on this side to hear. We wanted increasing milk components for so long now because that's what dairy farmers are paid off from. But now here, yes, milk fat has skyrocketed and take it off. Now, how can we make sure we're increasing milk protein at the same rate? It's very interesting with us in some of the amino acid studies because we increase an amino acid and she does increase milk protein, but she's also increasing milk fat to a greater extent. So, we're thinking, amino acids, milk protein, but that's not always, a linear relationship. It's very systematic in how the mammary gland works. And so now we're trying to figure out how we can not redirect, but maybe understand how the mammary gland is making decisions to synthesize fat and protein to sort of direct some of those nutrients more to protein. So one idea we have is as we're increasing amino acids to synthesize more milk fat, maybe can we layer on more dietary fatty acids to maybe redirect some of that energy that's being used to synthesize de novo fatty acids to maybe be used for milk protein. There's also, the branched chain amino acids are very important for casein synthesis. So maybe potentially we're limiting on some of those amino acids, especially in these high producing, high genomic herds. So maybe we need to shift focus. A lot of research in amino acids focuses on the big three like lysine, methionine, and histidine, but there's also, other essential or non-essential amino acids that are also important for casein synthesis. Proline is a big one to form casein and create that 3D structure. So maybe the dairy cow's limited on proline in some diets. So we're trying to figure out, the best balance and ratio of some of these nutrients to be able to increase milk fat and milk protein.
Yes, I have a couple questions about this. So when you talk about supplementing dietary fat, I always talk about de novo fatty acids as basically like free fat. Not really. Like we know it's not free fat, but de novo fatty acids are basic. You let the cow do her job, and kind of like support that rumen health and get that de novo production. So do you have any sense of? I know it's kind of a wild west right now, so maybe you don't have a clear, straightforward answer to this. But do you have any sense of like the economics of some of like adding some dietary fat to be able to shift that efficiency towards protein synthesis?
That's very interesting. Was actually just thinking about that. Of what's more expensive. When we think about amino acids or fatty acids, and how can economically we create a balanced diet to be able to increase that. I guess directly, economically, I don't have a good answer for that. But biologically, there may be some ways we can balance some of those nutrients. I think maybe I think there's sort of the sweet spot, I guess is what I call it, of meeting amino acid requirements and then also fatty acid requirements. So is there a sweet spot of, can you overfeed fatty acids too much, dietary fatty acids too much, and then you get a drop in milk fat? So yeah, I guess I don't have a great answer of like economically, but I think biologically there may be some sort of sweet spot of how you can balance those nutrients.
I don't know if anybody has a good answer for economically right now.
Yes.
So it's okay that you don't. Yeah. But yeah, there is certainly that give and take, right? Like,
Yes.
if you have to, well, if you're going, if we're going to see people maybe getting discounts for milk fat that's too high, and it's so counterintuitive, what you're saying is that, well, maybe we can actually supplement some of those dietary fatty acids. It's kind of, maybe it does pay off or break even at some point.
Yeah, it's very interesting. There's been some work too, out of the law group too, where I did my master's with some fatty acids that may be important for or may increase insulin signaling. So going back to some of Dr. Bauman's work that was done with the clamps, and insulin may be an important signal molecule for milk protein synthesis. Is there an interaction there with, say, I know they've shown oleic acid increases insulin secretion. Could that be a way of also increasing milk protein? So it's very interesting how feeding amino acids, you get milk fat, maybe feeding fatty acids, you could get milk protein indirectly through increasing insulin signaling, and then increasing milk protein synthesis.
I'm excited to read your dissertation when it's done. Yes.
Yeah, we like to say, we talk about the cow as a system and how we have to understand it all as a system. One nutrient doesn't just go to one thing. It's very systematic. And so sometimes it's fun to think about where all these nutrients can get directed to a milk fat or protein or lactose or, whatever is where she's demanding that nutrient.
Yes. That's so, I feel like we used to kind of have this idea that, okay, milk has these building blocks. So if we provide these building blocks, then we will get milk, right?
Yes.
But all, like, you're exactly right. All of those signaling interactions that happen within the cow make it really hard to predict, especially when you throw a rumen on there too,
yes.
Right? So speaking of that, I kind of want to, so you mentioned proline earlier as potentially one of the amino acids that you guys are interested in. Do you see that being something that we supplement as a protected amino acid, or is this, something that we're going to be looking at just providing in the basal diet, or what does that look like?
Yeah, that's a good question. I know Mike has talked to, I can't remember, it was somebody previously who had made sort of an offhand comment that proline is sort of, I guess, indestructible is probably not the best word, but sort of indestructible in the rumen. So it may be an opportunity where we could just feed proline in the diet and that will end up in the small intestine. I guess there's more analysis needs to be done to better understand that. There's also some data that shows arginine as a backdoor to proline. So we're also thinking about maybe can you supplement a protected arginine? There are some, I know there's been research done with protected arginine, maybe to be a backdoor to proline synthesis. So we're trying to figure out different ways to get more of these amino acids in diets and then thinking about next steps commercially. So one study we have planned in the next couple of months, we want to look at maybe protecting some branched chain amino acids as well to get more of those past the rumen and absorbed in the small intestine. So I think we're trying to, we focus on the big three, and even there's 10 essential amino acids, but there's 20 plus amino acids that may be important for synthesis of fat and protein, and maybe we're forgetting about them or we're not paying close enough attention to what, deficiencies in those might mean, especially for milk protein synthesis. And, we're trying to also think about this from an environmental standpoint, because one way you can get more amino acids is if you just feed more protein in general. Mm-hmm. That's not always going to equate to more amino acids absorbed post-ruminally. Some of that's converted to nitrogen and then it just goes out the back end. So as we move forward with these high genomic, high producing cows, how can we make them more efficient energetically and then also on a nitrogen basis?
Yeah. So we've talked about energetic efficiencies along the way. In your studies, what specifically have you found about energetic efficiency when you're supplementing some of these nutrients? Yeah.
It's been really interesting for us to see these sort of shifts in how she uses these carbons and uses this energy to synthesize fat and protein. We use energy corrected milk sort of as our overarching metric because that captures if she's making more volume, more protein, or more fat. So we try to use that as an indicator of how she's responding to amino acids or fatty acid supply. One sort of analogy we like to use is the cow or the mammary gland is sort of like a conveyor belt. she's always running. These components are always being synthesized. But if we can provide her with more mechanics or nutrients for her to run more efficiently, then that's where you get more fat and more protein on the back end. So it's interesting. In some of the amino acid studies we've done, the basal diet is very similar. So energetically, the energy intake of the diet is similar, but we layer on maybe 20 to 30 grams more of an amino acid, and we see an increase in milk fat synthesis, suggesting that there's an energetic efficiency increase by providing more amino acids. So it's very interesting for us to see this relationship. And, she's not eating more energy necessarily, but she's making better use of the energy she has and of the nutrients she has.
So what's next? What are some next steps you have for research projects that you're looking at?
Yeah, so I'm really excited for the next study. We're planning a fatty acid amino acid interaction study. So we're going to feed 2 levels of amino acids and then fatty acids, mainly palmitic acid, stearic acid, and oleic acid, with different levels of amino acid supply. We're really trying to balance for all 10 essentials and maybe look at some non-essentials to make sure we're efficient in all of those amino acids. So we're going to look at how sort of a factorial design with different levels of the different nutrients and then one sort of combo diet to see if we can get a bump in milk fat and milk protein. So we're trying to tease out how, from a component standpoint, how she responds to the different nutrients, and maybe hopefully with a combo we can get a bump in both. We also want to layer on some insulin too with this at the end of the study to see if maybe insulin is important to directing some of these nutrients. I know it sounds crazy to give insulin, like thinking from a practical standpoint, giving insulin to a cow, but if that's important for directing some of these nutrients to fat or protein, it's just interesting, I think, for us to think about, especially going back to some of Dr. Bauman's work.
Yeah.
And then at the end, we're planning to take some biopsy samples to look at what is the protein and gene expression going on in both the mammary and the liver to responses in these different nutrients and insulin. So going back to that relationship between amino acids and de novo fatty acid synthesis to see if in the mammary tissue we can see, if those are important for different cascades. So I'm really excited about this study. I think it's going to be, both practical and mechanistic when we think about, how she responds in milk components, and then also from a biopsy standpoint, what are some of those cascades look like in response to amino acids or fatty acids?
It sounds like it's going to be like very mechanistic, but in a way that's going to answer a lot of very applied questions. Very cool.
Our biggest thing is really hoping to make sure we meet all amino acid requirements, especially when I mentioned, branched chain amino acids are important for casein synthesis. Maybe that's where we can get more milk protein if we're providing more building blocks to be able to synthesize casein.
Very cool. Are you going to be looking at like microbial flows or anything like that?
No, nothing in the rumen. Just dietary and then in the mammary gland. Yes, we actually we thought about that at one point. Mike came to me and he was like, "Do we need to cannulate a bunch of cows?" I was like, I don't think for this study, maybe future studies, but...
the answer to that question is always yes.
Yeah.
In my opinion. I love the rumen, but...
Yes. Well, it's funny. It's actually good that you brought that up, because one thing we've also been talking about is how does the microbial profile or protozoa profile of fatty acids maybe affect the flow of fatty acids to the small intestine, because those protozoa really like the unsaturated or essential fatty acids. So maybe are they going undocumented, but maybe we're not capturing all of the fatty acids that are actually reaching the small intestine than we realize. So maybe that could be providing more fatty acids to the cow as well.
The protozoal, like their contributions to amino acids, I guess thinking about the fatty acid side is,
yes,
that's unique too. Have you done that yet, or is it something that you're...
No, it's something on our to-do list.
Okay. All right. Very cool. Separating protozoa is a lot of fun.
Yeah. So. I know they've done it a few times in the lab, so they should be experts on it. Mainly amino acids, but it'll be interesting to do fatty acids as well.
Adiseo, a global leader in nutritional solutions and the provider of Smartamine N, the best-in-class rumen-protected methionine product for dairy producers who want to optimize milk production, capture more value from their components, and maintain their lifetime performance of their herds. For more product information and to calculate your return on investment when you balance your feed with amino acids, go to milkpay.com.
For
more than 25 years, Agrarian Solutions has been guided by our RISE core values: relational, integrity, strategic, and excellence. Since 1996, we've been a global leader in proprietary bacteria technology, delivering research-backed microbial solutions that help livestock defend against environmental challenges like mycotoxins, supporting health, performance, and reproductive success. From science-driven innovation to trusted relationships, Agrarian Solutions exist to help others succeed. Learn more at agrariansolutions.com.
It's so interesting. And then so many other questions to answer after that too, because protozoa won't flow into the small intestine at the same rate as everything else. And it sounds like you're going to be you've got a lot of ground to cover in your PhD. I'm not sure how far in you are, but it sounds like you've got at least 10 years.
I'm on my third year, so yes. Okay. It was funny. We had a meeting, I think before the holidays, and somebody had said that it's a very fun time to be a grad student in dairy science, which I couldn't agree more. I feel like there's so much fun stuff we have to learn in the way cows are changing and, how they're responding. And like you talked about milk, fat, and protein, it's very fun to learn from them and see all the extraordinary things they can do.
I love that. I feel like, and this kind of gets to the one of the last questions I want to ask you, as we're continuing to learn more about the biology, cows are also changing too, right?
Yes.
So it's constantly trying to play catch up to where the cows are at, because they are changing just as quickly as the research is coming out too.
Yes.
So, you do your final studies, you get your dissertation written, like how's the industry going to be better because of the work that you're doing?
I'm hoping we'll have a better understanding of how maybe we can balance diets to increase milk fat and milk protein. So I'm hoping some of this will answer some of my research will answer some of the milk protein questions, and how we can sort of, play around with some of these nutrients to shift towards fat or protein. We always joke that we would be millionaires if we could predict how cows respond in terms of milk fat and milk protein, but we never know, so it's fun to learn from her and see how she makes those shifts. So I'm hoping with my research, we can gain more knowledge on how we can increase milk protein, and maybe moving forward, how we can then maintain this preferred ratio, I guess, of fat and protein in milk components to, allow dairy producers to still be profitable on both sectors of milk components. So I'm hoping there's, as I mentioned, there are a lot of mechanistic things, especially for the study that we're planning, but there's also a lot of practical knowledge that can be gained from, understanding how these different nutrients affect how she's synthesizing milk.
Well, is there anything else that we need to talk about that you feel like you didn't get enough of an opportunity to discuss about your research and your program?
I think we covered most of it. It's fun to talk about what we're doing here, and sort of, like you mentioned, all the great things that cows are doing, and like you mentioned, we're sort of playing catch up to them and understanding how, they're changing every day, and understanding how, maybe how genomics or genetics plays into this interaction with nutrition as well. Might give a talk at CNC with this genomic by nutrition interaction, where he has talked to people and they've said, every calf that drops is a new genotype. So how do we keep up with that if, their turnover is so great? And then how do we think about their nutrient requirements? Is that changing? Do we have to reevaluate how we think about amino acid requirements or fatty acid requirements? Because, I think she probably does have a fatty acid requirement. It's just not as well defined as how we think about amino acids or other nutrients. But so I think there's a lot of opportunity. We're always, like you said, we're playing catch up to her. So we can always learn a lot of information from her.
Well, very exciting. Like I said, I'm excited to read I don't say this very often, but I'm excited to read your dissertation when it's done.
Me too. I'm excited to learn a lot.
Sounds like there's going to be a lot of good stuff in there.
Yeah, I think everyone's pretty excited here for a lot of the work that we have next, especially this study, to see, can we change milk composition in and sort of maybe better predict how these nutrients are affecting and how they're being allocated in the mammary gland.
All right, before we move into our 3 questions that we ask everybody, is there anywhere that people can go to follow what you've been working on or follow more about you?
I am on LinkedIn, although I don't post as much as I probably should have. I do have a few papers out now, and then I had one this past fall, a CNC manuscript looking at sort of a combined meta-analysis of some studies done in the lab previously, looking at how amino acids shift milk composition. So there's some data on that, but I guess stay tuned for more information about this next study. Hopefully we get some good, interesting results.
Are you submitting anything to ADSA this summer?
Yes, I'll have 3 submissions, I believe.
1 month until abstracts are, well, a little over a month until abstracts.
I know. Yeah, I'm hoping to maybe submit the meta-analysis data. So hopefully I'll have a poster on that this summer.
Very cool. Very cool.
It's time for our famous 3.
Every dairy producer knows longevity doesn't happen by accident. AgriComfort, the cow comfort specialists, design rubber flooring and stall products that help support mobility and keep cows productive longer. It's about creating an environment where cows can perform year after year, because when she stays healthy and productive longer, that becomes part of your story. AgriComfort, because her longevity is your legacy. Visit agri-comfort.com to learn more.
All right. Well, with that, we will go ahead and get into the 3 questions that we asked all of our guests, which you are aware of. So, thankfully, we're not springing that on people anymore. I don't think we ever really sprung it on people, but yeah. So our first question is what is your favorite dairy-related book or resource?
That one's a hard one. To me, I don't know if I have necessarily, like, there's certain books that I focus on, like there's a milk fat sort of Bible, as Dr. Locke would call it, with all fatty acids. But one thing I really enjoy is looking at older literature and really going back to see sort of where it all began. And then it's really fun for me to read and understand what they knew at the time, and then work my way to present day to see how much knowledge we've gained. Because I still think there's a lot of power in some of that older literature and understanding, sort of where we started and where we are today. So I really like diving into a lot of that and then reading up towards present. So I know it's not a good answer. It's not one specific book, but I think it's really important to really focus on some of the stuff that's been done in the past, because a lot of it is still very relevant today. Even though the cow is changing, the biology is very similar.
I love that answer. And I agree with that a lot. I get a kick out of reading old papers too, because like, when you go way back, like before there was IACUC, and it was just like old scientists who would be like, yeah, I wonder what happens if you feed a cow sponges. Like, you could just have an idea and then do it. And I should say, since we're recording, IACUC is very important, and it's very important that we like have an institution that's going to hold us accountable, because not all of those studies were very good for animal welfare. So it's not that I want to go back to that. I should clarify. It's fun to read about. Yeah.
I was just reading one on energy, and it was so funny because they were talking about differences. They had 2 cows, which they used to name in some papers, which I find that very funny. 2 cows that sort of allocated their energy different, or they were trying to understand differences in energy. And they were basically saying how they know there's a difference in the diet, like digestibility wise. They just didn't have a way of like quantifying it. So it was very interesting to see, like, they knew that there's differences in digestibility. They just weren't quite there yet. So it's very fun to read.
Yes, that is. I'm with you on that one. I know it's not a direct resource, but I'm with you on that. So
yeah.
All right, our second question is, what is your favorite non-dairy related book or resource?
I guess one fun podcast or resource, I really like baseball. So I listen to a lot of baseball podcasts. I'm a big Red Sox fan. So that kind of keeps me a little grounded when I'm thinking about research. And it's kind of my fun time to listen to podcasts when I'm in Excel or doing other research related stuff.
Baseball people can be like the highest nerds, right? Like just when it comes to like statistics and numbers. And,
yeah, it's funny how it's like you have the whole baseball people who's just like, baseball is baseball. And then you have newer fans who are like, well, there's statistics and there's all these numbers that are important. So it's very funny.
So where do you find yourself on that spectrum?
I'm probably in the middle.
Okay.
I honestly don't really understand a lot of the new statistical stuff they do. I just enjoy watching. I used to play softball, so I kind of like the old style baseball, but I do understand that there is a place for statistics in baseball. So I'm kind of in the middle, I think.
That's a fair answer.
Yeah.
Good political answer, yes. All right, our final question is what do you think sets people who are successful in the dairy industry apart from those who aren't?
I think one big thing I've noticed about people in the dairy industry is they're very driven and they're very passionate, and they really love what they do, and they really love dairy, which I think is really important. And it's, dairy is, whether you're at the farm level, if you're in a dairy plant, or if you're in research, it's a lot of work. It's hard work. It's long days, and sometimes things don't go the way you want them to. So I think for people in the dairy industry, it really just shows their passion and their drive to still be here and to still want to flourish and further research or further cows and our understanding of cows. So I really think that's a big thing is their passion, and it's a lot of fun to be a part of it and to be around a lot of people who truly love dairy cows and truly love the space that they're in. So.
Well, very good. Well, Alex, thank you so much for joining us on this episode of the Dairy Podcast Show. It was great to hear more about your research and what you have going on, and excited to see what your lab keeps coming out with.
Yes, thank you. Thank you for having me. This was a lot of fun.